Good morning, good afternoon, and good evening, guys. It's me again, Dylan. Thank you for checking out this video. If you're new to the channel, please subscribe and also click the bell button if you want to. If not, that's all right. At least I get to share my time with you. Thanks for hanging out with me. And if you're a regular subscriber, thank you so much. Again, it's really appreciate you hanging out with me. Anyway, let's get this started. So in today's video, as probably you would notice in the title of the video, we'll be talking about Dmvpn, like the basic configuration. It's just one of our how-to training or video series. Okay, so what is Dmvpn? So Dmvpn is basically like a logical hub and spoke tunnels between endpoints. Depending on the phase that you use, you can do spoke-to-spoke traffic depending on what phase that you're using. But obviously, phase three would be the most recommended. It's not only can you do like spoke-to-spoke traffic, you can also do some sort of summarization. Now, with DMVPN, oh, by the way, DMVPN, so imagine if you're familiar with site-to-site VPN, from the term itself, site-to-site, it's basically you have like two internet connections. If I can draw that out. So imagine if you have site A, site B, and they're all going to this cloud called the internet. But for some reason, or you want to communicate between LAN segment A and B, you can actually create a VPN. Either you do a crypto map or you do some sort of tunnel. Sorry about the drawing, wherein A and B would actually see each other, communicate each other as if they were like on the same LAN segment. Okay, they wouldn't feel that they're actually going out the internet. So the problem with this kind of solution is scalability. So can you just imagine if you have like another site here and another site here? So let's use a different color. So let's say this is C, this is D. So if you want them to communicate with each other, well, obviously if you ask me, I work for a service provider, might as well go for an MPLS network. It's a bit expensive, but or you can do this. But the issue with this one, since it's a site-to-site VPN, that would mean from A, you need to create this tunnel here, you need to create this tunnel here. Then it's going to look like a star topology where each one would need to have their own link with each other. Okay, so it's not very scalable. And, what if in the long run you get like 10 different sites? But then again, I would still recommend to get into an MPLS network, get your provider if you do have the budget. But anyway, that's not the point of this video. The point of this video is with the MVPN, right? If you have like multiple sites, okay, and they are all connected to the internet, right? Kind of like that. So if you want them to communicate with each other, what you can do is you can actually create some sort of a hub and spoke topology wherein one of these guys, we're just going to get into the very basics of the MVPN. You can do like multiple spokes, multiple hubs, but in the basic concept, like in this network, all going out the internet, you can assign one of these branch sites. So hopefully this would be your data center. Um, it's going to be the hub, and everybody's going to be the spoke. Spoke 1, spoke 2, spoke 3, and each one of them, they're going to create some sort of peering to the hub. Okay, so traffic will now flow from if spoke 1 would like to talk to the LAN segment of spoke 2, or well, you can even have like a network somewhere here. If spoke 1 would like to talk to the LAN segment of spoke 2 or spoke 3, traffic would then go via the hub, then down to the spoke. Well, that's phase 1. Once you get into like the phase 2 or phase 3 of DMVPN, once they've started, the initial phase would be like, oh, well, the initial setup would be like this. First time traffic will go that way. But once the peering has been established between the two spokes, instead of going to the hub, what's going to happen here is traffic is going to start flowing in this direction while there is traffic. Some sort of gypsy magic, as one of my colleagues would say. Okay, so this physical connection doesn't exist, but what's going to happen there is this hub right here is going to say, I don't need to be part of the data plane. So might as well you guys talk to each other since the traffic is kind of like IP redirect. So instead of going back to the hub, it goes straight to the spoke where it's after that user, Bob, who's right here. Okay, so that's the beauty of DMVPN. And another beauty of DMVPN, it's templatable, if there's a term. Like the hub technically doesn't change its config. You just keep on adding spokes, and all you have to do is change the tunnel interface on the config. Basically, your own tunnel IP address. You template it once, and you're good to go. Okay, so that's why I like. This is what I like about the MVPN. It's very simple, but mind you, kind of like IPsec VPN, it won't just work on any of your router. You have to make sure that your iOS or your license on your router does support DMVPN. So you might need to check, the documentation of your router and or the iOS that you have. All right, or the license particularly. Okay, so let's start. Oh, by the way, what are the components of a DMVPN? What do you need aside from the license to support the technology? One, it's composed of your multi. What's wrong with my handwriting? Okay, so it's composed of your multi-point GRE. Okay, so this is basically the tunnel itself. Then you have your NHRP. This is the one that will be doing your mapping between your overlay and your underlay. Underlay would be your internet. You need to have like a public IP in order to make this work. Yes, it does support like you might have a question, Dylan, what if I'm natted? Because most service provider NAT my I may not have like a public IP. There's a workaround, but you need to go through the Cisco documentation for that. And I'm not going to cover that in this video because I have limited time. Okay, so and the next component would be your IPsec. Okay, IPsec crypto profile to be exact. Then you have your routing. So you can do all sorts of routing here because it supports multicast. You can even do static routing. Um, you can do RIP. You can do OSPF, which it's a bit complicated if you're gonna do OSPF. You can do EIGRP and BGP. Though if you're gonna use RIP, there's a caveat here. If you're using RIP or EIGRP, just be mindful of what's that? Yeah, just be mindful of the trying to remember. split tunneling. Yeah. So just be mindful of that. The concept of split tunneling, wherein if it receives a packet here, it's not going to advertise it over on the same packet where it receives uh, the packet. Okay, so it can advertise it anywhere else, but it's not going to advertise it to the same interface where it received it. Okay, so you would need to deactivate split tunneling on the tunnel itself. I will show that to you. Okay, I got cut there. Okay, so let me just. I think the reason I got cut there is because just like that. Sorry about that. All right. Anyway, as I was saying, all right. So let's start configuring this thing. Let's erase that again. So as I was saying, if you're using RIP or EAGRP, just be very mindful of the split tunneling rule. Okay, you need to deactivate split tunneling if you are to use RIP or EIGRP. All right. So now let me show you first our topology or my lab here. So we have like five routers. Okay, we'll pretend that they're all connected to the internet or to the interweb. This looks like an avocado, but it's color. So we'll have, let's change color. We have router 1, router 2, router 3, router 4, and router 5. So let's say company A or company triple A, they have 5 sites. So let's say R5 is the DC, it's the data center. And let's just say they don't have a budget of getting into an MPLS network, and they got themselves like some cheap internet service. But they want to create like inter-branch communication with each other. They can do your typical site-to-site VPN, but as I've said earlier, that's gonna be a bit tedious because can you just imagine R1 would need to have a pairing with R2, R3, R4, R5, and same goes with the other. What if they add more branches in the future because they are in the period of growth? Or they can do that, or they can do like a Dmvpn configuration wherein R5 right here, which is the DC, can act as the hub, and everybody else is going to create a pairing with the hub and R5, which is the DC, and they can, form a hub and spoke topology, something like this. And that's what we're going to create. Okay, so now let's move into the. So with this in mind, I'm going to keep this in the background. So we have a diagram. Okay, so I think I've configured this is on gigabit. Our internet will say, let's say our internet is on gig. I think it's on 100. Yes, it is. So we'll pretend that's our internet connection. By the way, on the background, everything is on the 169.254.100 network. Okay, so for ease, so you can follow along. So 1 would be router 1, dot 2 would be 2, 3, 4, and you get my drift. So common rule, as long as these spokes and the hub can actually communicate with each other, as you can see here, I can ping 4, 5, and 4, and 5. Okay, I am all good. All right, so now let's do the config. So I've said earlier, I think I mentioned this before, IPsec is not really a requirement, but obviously for obvious reasons, you would need to protect your tunnel. Okay. All right. So the first thing we need to do is we need to create a tunnel. So we'll put okay. So we'll put our tunnel. Sorry if my audio there's something wrong with the PC. Sorry about that. I'm still trying to figure that out. What's causing that? But anyway, let's create a tunnel. Let's say tunnel 0, and we'll create. Let's say we'll put them in the 10 network, 10.0.1. Okay. Okay. So let's start with configuring NHRP. So this is the MGRE part. Okay. Then the next command that I'm going to put in here is authentication, NHRP authentication. So we'll call it Cisco. Then the next thing that you need to do or you need to put in is the mapping between the overlay. Okay. So again, the overlay is the the tunnel interface of the server. Okay, the server. So I'm on router 1. If you look at our diagram here, we're going to do the mapping between the overlay, which is the tunnel, private IP, over the underlay, which is the internet. So in this case, it's going to be 10.10.0.5, and we're going to map that to its public IP of 169.254.100.5. Okay, then the next one would be NHRP map multicast, and this is going to be for the public IP of the hub, and IP NHRP network ID. Okay, so we'll just pick one. So this is, like I said, this will be useful if you're gonna do network ID. You use that for multiple hubs setup. I'm not gonna get into that. Next, we're gonna go for the IP NHRP NHS. This is basically telling the spoke who is your server. So our server here is 10.0, 10.10.0.5. Okay. Ooh. If I know how to spell. And HR. Ah, sorry about that. And HR and HRP. Okay. Then we now go to the tunnel. Let's set up the tunnel. Tunnel source in this case would be the interface of our WAN facing the internet. Tunnel source gig 1.100. Okay, then I'm gonna do tunnel mode GRE multi-point. I'm gonna do phase 2. The only difference between basically phase 1 and phase 2, let me touch on that. If you're doing phase 1, you on the what do you call this, on the spoke itself, instead of doing tunnel mode GRE multipoint, you do tunnel destination, then the public IP of the hub. So the thing with this one is like you won't be doing spoke to spoke traffic, which I wouldn't recommend. So let's not go through that. So I'm just gonna go back to tunnel mode GRE multi-point. Then we need your tunnel key. Tunnel key will set to 1, and that's it. You're done with your spoke. So if we do show run interface tunnel 0, that is basically your config for your spoke. Okay, that's without That's without the IPsec component, but that thing will work. Okay, now let's go to the spoke. Oh, don't mind this because in the background I used to use this lab to create MPLS network. Okay, so now let's get MGRE on this guy right here. We're gonna let's complete my commands. 150. Oh no, I'm on the 10.10. 10.10 dot 10.10.0. Okay, so 10.10.0.5. Okay, so we do the IP NHRP authentication. Type Cisco IP NHRP map multicast dynamic. Okay, so by doing NHRP IP NHRP map multicast dynamic, the difference between the spoke is we actually please map the private IP to the public IP of the hub. But on the hub, since we do not know where it is coming from, okay, that's the beauty of it. But on the background, it will just determine like, okay, I know it's coming from this public IP. It maps to its private IP. Okay, so that's the simplicity of it. Then the next one that we're gonna need to put in here is network. So network ID is 1. IP NHRP network ID 1. And this shall run interface tunnel 0. Okay, I think I forgot to let's do this again. Okay, so if I do a no tunnel 0, no interface tunnel 0. Okay, let's do this again. Tunnel 0 because you might get confused. How come that thing just appeared? Okay, so let's do this again. So IP address 10.10.0.5, 255.255.255.0, IP NHRP authentication, Cisco, IP NHRP map, multicast dynamic. And I think that's it for the IP NHRP section. Then you need to go to your tunnel. Then you're gonna have the same tunnel source, which would be your WAN interface. Then tunnel key 1. And also tunnel mode multicast, GRE multipoint. And I think that's it. So our tunnel went up. Okay, so if I do show Dmvpn, and it's down. Okay, so why is it down? Show IP NHRP. There's nothing there. So if I do show tunnel 0, okay, IP. Oh, I forgot the network ID. Okay, so tunnel. Okay, so interface tunnel 0, then IP NHRP network ID 1. Does it match? Does it match? Yes. So it does match now. Okay, so do show Dmvpn. Okay, So now it is up. So if we do show interface, tunnel 0, and if we do a ping, do a ping to 10.10.10.0.1, and that's a success. If you do show IP route to the 10.10.0.1, it's going to tell us that we are directly connected to it via tunnel 0. And like I've said, this is the beauty of Dmvpn, because all you need to do, and the tunnel here now is it's perfect. You don't need to touch it anymore. So now this is what you call now your template. So if I paste that here, so if I change this to 2, copy that, copy, go to router 2, enable, Ctrl T, paste. That's it for router 2. Then I I can do it here actually, but it's just gonna winch at me in a bit. See, it's gonna winch at you. Receiving registration reply error. Unique address registry already exists, because somewhere in the network there is already a 10.10.0.2. So let me change that 3, and let's do the same thing here. Okay, before it starts whinging, hurry up. Okay, let's 4. Okay, too late, but that's fine. Okay, so show commands. Show IP NHRP. Don't mind this because I have an existing on router 4. There's also a separate DMVPN that exists. We're actually after this one. Okay, so this is telling us that it's actually in use. Another command that you can actually use is show dmvpn. How come? Oh, okay, so it's right here. So I got confused again because, as I mentioned earlier, I have 2 tunnels on this router. So this is telling us that my peering to this public IP is mapped to its private IP, and the status is up. And it's been up for like 35 seconds, and S is for static. We've statically assigned that to be our server. Okay, cool. So now let's look at what the server is seeing, or the NHS or the hub. So let's do show Dmvpn. Okay, so we can see here that it's dynamically learning all these spokes, and this is the mapping. And you notice it just learned about it, even though it doesn't need to know like where's the source of this one. Okay, so it just automatically learns about it. All right, so if I do show, okay, so if I do show IP NHRP, and it's going to show you the same thing. Okay. Okay. Now let's do some EIGRP on this thing. Okay. Let's do name mode. Router EIGRP named, address, family, IPv4, unicast, autonomous. I'm gonna complete the 100. And network will advertise the 10 network 10.10.0.0.0.0.255. And I have loopbacks here on this router. So we'll do the loopbacks, which is on the 150.1 range 0.0. Okay, we're gonna do it like this. 255.255. Okay, then we'll do the same thing on the spokes. We're gonna do router EIGRP name router EIGRP name. Is it the same name? Okay, name, address, family, IPv4, AS. Okay, so either you can do it this way. Either you can say address family IPv4 unicast autonomous system 100, or you can do this as well. Same thing, same but different. So let's do the network. 10.10. I'm forgetting the period. 10.10.0.0. Okay. Network statement. 0.0.0.0. Scatter McMara would say perfect. Okay, so if I do show run section router, would this work? Yeah. Cool beans. And now I wonder, is the peering up? Okay, cool. So the peering is now up between, we are learning the 150.1.5.5 coming from the hub itself. Now let's do this with the other sparks. Now I'm feeling a bit lazy now, so we're just gonna do the classic mode. There's two ways of writing. If you're studying for the CCNA, I'm not sure if they've already updated this. There's the new version of writing EIGRP. It's kind of like BGP. The AFI, SAFI, the address family interface. So the name mode, it now supports address families. So I'm gonna do classic mode on this one. 0.0.0.0. The network. Okay. So number 3, router 3, router EIGRP 100. Network 10.10.0.0. Okay, let's see. Show IP route EIGRP. Yes, it's learning it. But what do you notice? Is router 4? Okay, I haven't configured router 4 yet. So okay, so router EIGRP. Again, if you do notice that once in a while it gets muted, apologies for that again. There's something to do with my setting on my computer. Whenever the Windows machine does something, it mutes me. Sorry about that. 10, 0, 10, 0, 0. Okay, I know you guys would probably be saying, Dylan, why didn't you just put it in Notepad and paste it? Well, I have an excuse. I want you to follow along with me, if you can. All right, now we have our tunnels up, and for some reason, the LDP neighbor went up as well. Don't mind this. So just I do show IP route EIGRP. I'm pretty sure I'm gonna learn all other routes, but we're after this network right here, and it's learning via the other tunnel. Okay, let's just not mind. You know what? Here's what I'm gonna do. Um, I'm gonna shut that tunnel down. Shut down. Okay. There you go. So if I do show IP route, EIGRP, there you go. All right. What do you notice, guys? You notice that, let's go back to our diagram here. The idea is R1 should be able to communicate with R2, R3, R4, and R5. But if you look at our routing, but if you look at the routing table here of one of the spokes, it's only learning about the loopback of router 5. Right? Did you notice that? Okay, so if we go to router 1, it's the same thing, right? It's only learning the loopback of router 5. But from router 5's perspective, if I end that show IP routes EIGRP, it has learned all the other routes, all the other loopbacks from each spoke. As if you remember what I've said earlier, the rule of split horizon. Okay, so if I go to router 1, I won't be able to ping. Let's ping 150.1.2.2. Yeah, there's nothing there. Okay, so how do we deal with this one? So all we need to do is, if you do show run section router. Okay, so for some of you who might be studying, who's not familiar with the name mode, so if this is classic mode, you just go to the tunnel interface and you do no split horizon. Okay, but with the named mode, let's do this. Router, go to router EIGRP name. Okay, so AF interface tunnel 0. Oh, let's go to the address family first. IPv4 unicast autonomous system 100. AF interface tunnel 0. No split horizon. And you'll notice it did a resync. Okay. Router 1, earlier, we are only learning the 5 network, or the 5's loopback via the overlay. So now if you do show IP route EIGRP, it's gonna start learning all the other loopbacks from the other routers. Okay, so that's it. It's now 40. minutes. I think I'm gonna end my video right here. I'll do a part two, and it's about applying IPsec uh, and the crypto profile on this one. I hope you enjoyed this video. I hope you learned something. It hopefully it would help you with your work, skill you up, also with your studies, whatever level it is, CCNA, CCNA, CCNP, CCIE. Okay, this has been Dolan again. Thank you so much for hanging out with me. Thank you. You have no idea how much I appreciate you guys. Again, give a like if you like this video. Subscribe if you're new to the channel. And again, remember guys, keep on studying. It's all worth it. Believe me. Cheers, guys. See ya.